All right. So I wanted to look at a little bit how we do calculate means and variances in Excel relatively quickly. So I've got this file, chapter 3, crime blank. One of looking at some group data stuff, correlation, but here we're just looking at these descriptive statistics of like the mean and the variance. So up here, I'm going to calculate a few things. So these are all the different things that we talked about, right? Measures of central tendency, mean, median, and the mode, variance, standard deviation, or measures of dispersion. In fact, I'll add in another one. I'll do it down here. We also talked about the range. Okay. So if I want to find the mean, right? I kind of showed you how you could use Excel to be a calculator just to add up all the values and then divide by the total number of observations you had in the video where we were just working through the theory. So technically, I could use that sum function. And here we're going to think about, we're going to find the average population across 50 states. So I'm going to select, once again, Control Shift or Command Shift on the Mac, hit the down arrow, selects the entire range of data. So I added up all the X values. I'm then going to divide by the total number of observations I had, which I said I can calculate using the count function. So count, once again, select the very first one, Control Shift, Command Shift on the Mac, hit the down arrow. Instead of scrolling up and closing the parentheses, I can just hit the return or enter button. It'll ask me, do I want to put that in front? Yeah, of course. And I end up with this mean. Okay. So what? Looks like it's 6 million, 6.3 million. Excuse me. There's a built-in function though, and this is where it gets kind of weird. So yes, we refer to this as the mean. A lot of people, like just in normal, everyday talk, we'll talk about the mean as the average, right? So in Excel, the built-in function for calculating the mean is actually called average. So I'll then find the average of this entire, oops, I didn't need that parentheses, the average of this population variable. Once again, instead of going up, closing the parentheses, I just hit enter. Sure enough, I get the exact same value. So that's how I would, two different ways of calculating the mean. The one is, I think, kind of nice. The other one takes a little bit more time. So we can also find the median. Now here, there's really no way to do this, but I mean, I guess I can technically like order these. There's some other things we could do, cross off the highest, lowest, but with a lot of observation like this, it's going to be kind of a pain. Luckily for us in Excel, there's a built-in median function, right? So I can go over, select that variable after I put in this word of median. There we go. And that should return to me the median. What else do I want to say here? Anything? I think so. Oh, so if I'm thinking about how do I label this? We'll just do it down here. What type of skew does this data have? So I don't have this like visual. I could do a histogram, which maybe I'll do here in a second to kind of prove that to us. But I've got what? A mean of 6.3 million and a median of 4.5. So the mean is to the right or greater than the median. I should have right skewed data. So we can kind of prove this to ourselves. If I just select the data, do what we did from last section, and I create a histogram real fast, sure enough, I've got this long right tail. Now, obviously, I'd probably want a few more bins than automatically did for me. But I can kind of see, right? I have a very right skewed data set. Okay. But I don't need to look at that visual, right? I can tell that just from comparing the mean to the median. Now, how do I find the mode? Sure, easy enough. Built-in function called mode. Select that variable, enter to kind of, oh, so this is going to be a problem. So why does it return to me an NA here? So this is the function that I use for the mode, but notice here what value happens the most often. Every state has a unique population. So none of them, right? There is no mode. Everything happens one time. Just to kind of prove to you that this works. Well, here. I'm going to copy and paste the same value. Let's say we have a 51st state and I have the exact same. Now, if I use the mode, it should tell me, Oh yeah, that value that happened twice. It's the only thing that happened twice. A little bit tricky. You've got a smaller data set where you have completely unique observations, but anytime you have any values repeated, you should end up, that mode will return to you a value. Okay. All right. Now let's go back and not actually use that, right? So I'm going to use the actual 50 states data. I'm then going to find the variance, right? So once again, how could I find the variance? So we know that we want the sum of the deviation squared. So I'll show you a long way of doing this. Nope, didn't want to do that. Wanted to hit insert. So I'll show you a long way and then a short way. So the first thing I could do is find the deviations from the mean squared, right? So I could say, okay, take the very first state's population. Sorry, I need a parentheses. Subtract the mean, and then square that value. Now, when I copy this down, I would then want to take not D2, right, not Alabama's population, but Alaska's. So I want this cell reference to kind of update when I copy it down, but I don't want the cell reference for the mean to. So we said we can freeze this cell reference, Command T or F4, or sometimes the function or FN key in F4 if you're on a PC. Now if I hit enter, notice it puts this in scientific notation. So whenever, anytime Excel does this a lot, anytime I have a really large value, if it gets large enough, it'll just do this E thing, which just basically means move the decimal point 12 places to the right. So positive 12 means move that 12 decimal points to the right. And I'm going to copy this down for every single observation. Excuse me. We then said, okay, how do I find the variance? That would just be the sum of all my deviations from the mean squared. So I'm going to add those up and then divide by the total number of observations I have here. Now I could use that count function with states. I know I've got 50, but use that built-in count function, right? So I'm just finding the sum of my deviations squared divided by the total number of observations, and I get this really large variance, right? So notice when we're dealing with really large values, well, yeah, I mean, the population deviations that I'm seeing here could be really large. So when I square them, they're going to be these extremely large values, right? Squaring, a couple million is going to be a crazy number, right? But it doesn't matter. We can still calculate. So just to prove this to ourselves, we could break this down step by step. What was the other way that we said we could do this? Oh yeah, we said we could just take the x values squared. So take the x values squared. Now I'll show you a shortcut here. If I ever do something, instead of dragging it down so I can copy it for every cell, if I've got a data set like this, see this little box in the right corner? When my cursor becomes this black plus sign, if I double left click, it automatically takes that, so D2 squared, and it updates the cell reference. And it copies it all the way down to the end of the data. So that's kind of a nice little trick. We then said, okay, we could actually calculate the variance by taking the sum of all of the x's squared. So I'm going to select that. All right. Subtract from that the number of observations. So I could use the count function to find that, or again, this one's kind of easy because it's 50. So there's the number of observations I have. I could then take that, oh, sorry. I need to multiply that number of observations by, I accidentally got out of this cell here. There we go. I'm going to multiply that by my mean squared, right? And if I'm just a little bit concerned, okay, oh yeah, it does the square first, but if I really wanted to be a little bit careful, put parentheses around this to make sure it's multiplying it by the mean squared. That's my numerator. I'm then going to divide that by the total number of observations. So once again, I could use that count function. Go over here. Could close out the parentheses. If I just hit enter, it's going to say, do you want to? Yes. Sure enough, I get the exact same value. So it doesn't matter which way we do it, we would find the same value. Now, we're never going to do this all by hand because there's this nice built-in variance function. Now, Here I was calculating everything as a population variance. So notice there are two variance equations that are built into Excel. The first is the population variance, which is var.p, right? And it says it's caps. If you just do it in lowercase, it knows what you're trying to do. So here I'm going to try to find the variance of my population variable. So Command Shift on a map, hit the down arrow, then hit enter to get back up to the cell. Sure enough, I get the exact same value. Okay. Now, if I had done, let's say I treat this as a sample, although I have all 50 states, I know it's not sample data. What should be true if I used that sample variance equation? Well, it's going to basically be doing all this work behind the scenes. So this built-in variance equation, it goes through and finds this additional column, which is the deviation from the mean squared for every single observation, and then adds them all up, then counts the number of observations and divides by that. Remember, the sample variance would be the exact same thing, but I'd be dividing by n-1. So dividing by a smaller number should make my fraction or my variance a little bit higher if this was in fact sample data. Sure enough, a little bit higher. Okay. All right. So it shouldn't be too bad, I don't think. Yeah, it should be pretty easy still. So two different ways of finding the standard deviation. The first is I could just find the square root of a variance. We said that all the standard deviation is, it's your variance, and then you have one more step, which is to take the square root. Okay. Now, I also have a built-in function. If I didn't have the variance already, standard deviation. Now, there is just one that doesn't have, and I think this defaults, I forget, defaults to population. Maybe it defaults to a sample. I never use this one because I always make sure I'm indicating, okay, do I have population data or sample data? Here I have population data, so I'll use stdev.p, right? I then select what I want to find the standard deviation of, so that's this population variable. Hopefully when I hit enter here, I get the exact same thing as when I took the square root of the variance, because what Excel is doing behind the scenes, it's going through, finding the deviation squared for every single observation, adding them all up, dividing by the number of observations, and then taking the square root for you. Sure enough, get the exact same value. So it doesn't matter which way we do it here, using that built-in standard deviation function, or if we had the variance, just taking the square root of that. How would I find the range? Well, I need the minimum and the maximum. And we kind of already, I think we used these in the last chapter's Excel, but min will find me the minimum of a variable. So I just select that variable, hit enter. Okay, so the lowest populated state is Wyoming, 584,000. Maximum, I can use the max, built-in max equation, hit enter. I'm sure this is California, right? I've got what? Almost 40 million, so 38 million people. And then how do I find the range? Well, that's just my maximum minus my minimum. And that's how we can do descriptive statistics when we have like population or sample data. Okay.